So, good morning, a warm welcome to all of you joining us from all corners of the world. As many of you know, last month, the Energy Efficiency Directive recast entered into force, and this provides the EU member states with a 2-year window to incorporate the directive's new provisions into their national laws. The directive is a cornerstone in the EU energy and climate policy, and therefore we, that are the European Copper Institute, Odyssey Muur project, and the European Council for an Energy Efficient Economy, ECEEE, are collaborating, and we launch this new webinar series called the Energy Efficiency Academy. The focus will be on this 2023 Energy Efficiency Directive implementation. If you have missed the former webinar, you can go to the Academy website, and I will share the link in the chat in a minute. Today's webinar is the second one in the series, and the first one with a focus on targets. Today we will zoom in on the transport sector. The EU has an ambitious transition goal for this sector, so I'm very curious to learn what the state is of this transition in the sector and at what pace the energy efficiency in the sector is improving, if it is improving, and will this be fast enough to achieve the goal? So to do that, join me in welcoming two distinguished speakers. We have today Bruno Lapillonne. He's co-founder, vice president, and scientific director of ENERDATA. And he brought his colleague, also from ENERDATA, Estelle Payan, energy analyst, and also a dedicated manager of this Odyssey database. So, Estelle, I think you're the first one to speak. I will stop, share my screen, and the floor is yours.
That's for the introduction. So I will briefly introduce the Odyssey Muur project, which was launched 30 years ago to monitor energy efficiency progress in Europe. It is supported by LIFE program from the European Commission. It is coordinated by the French Agency for Ecological Transition with the technical support of ENERDATA and Fraunhofer. Which reflects the structure of the project, which is divided into two databases, Odyssey for the data and indicators, and Muur for the measures and policies. Odyssey database is managed by ENERDATA, and Muur is managed by Fraunhofer. These databases are filled in thanks to the inputs of a network of 40 national partners. The databases covers the EU, the 27 member states, plus Switzerland, and we are currently adding the 9 energy community parties. Today we will focus on the Odyssey database, which contains data up to 2021 from national sources, and early estimates for 2022 calculated by ENERDATA will be added in the following weeks. In addition of the Odyssey database, you will find on the website 5 facilities which allow to visualize the key data of energy efficiency in Europe. And you may find on our website much more information, data, and analysis. So today I will present you the energy consumption and emission trends in the transport sector in the EU. Then Bruno will analyze the energy efficiency trends. Then we will conclude and listen to your questions. So first, let's have an overview of the transport sector in the EU. The transport sector accounts for 31% of final consumption without non-energy uses, and this share is growing. Oil is still largely dominating the transport consumption. Biofuels have replaced 2 percentage points of oil consumption, but electrification remains stable and quite low, below 2% of consumption. Decarbonization is thus really limited in the sector, transport accounts for 30% of CO2 emissions, which is a share that tends to grow and grow even faster than the share in consumption. Sweden is the top runner in transition in the EU, with the highest share of biofuels as well as electricity and the lowest emission factor. So in transport consumption is partly related to economic activity. So it's interesting to compare its evolution in orange on the right, on the figure, with the evolution of GDP in dark green. And you can see in light green the evolution of transport intensity. At EU level, we observed a rebound in 2021 and 2022 after the travel restrictions linked to COVID in 2020. And first estimates show stabilization in 2023. Previously, over 2013 and 2019, transport consumption increased less rapidly than GDP, which led to a 0.7% per year decrease in consumption per unit of GDP, which is the same rhythm as before the financial crisis in 2008. And after the COVID, this trend is back downwards in 2022. If we look at the country level, trends since 2013 are more contrasted than the EU average. In fact, transport consumption remained roughly stable in 6 EU countries, including the 3 largest. They are circled in blue on the figure. And transport consumption even decreased rapidly in 4 countries, circled in green, despite economic growth in these 10 countries. On the other hand, consumption increased less rapidly than GDP in 8 countries, as in the EU average, and grew at the same pace as GDP in 5 countries. And finally, in 4 countries, consumption growth was much faster than GDP. So a very contrasted situation. Now let's look at the breakdown of consumption by mode. On the right, you can see the breakdown in 2010 and 2022. Cars absorb around half of transport energy consumption, and so it's the dark blue in the figure, and they are followed by trucks and light-duty vehicles, which accounts for a third of consumption. It's the orange and the dark orange on the figure. The share of cars in transport consumption has slightly decreased since 2010, and domestic air and rail account for 2% of the consumption each, while water transport is only 1.5%. So this figure shows the trends in consumption by mode at EU level by period, one color by period. We observe a slow increase in consumption of road vehicles between 2013 and 2019. It's the period in light blue. Then, of course, the COVID. Passenger transport was strongly affected by COVID. For example, minus 15% for cars consumption and minus 53% for domestic air consumption. And then since 2021, we observe a rebound of more than 5% per year for all road vehicles, a trend that is driven by a strong economic growth, and for air transport, by the end of restriction, a rebound of 50%. Now let's compare the evolution of transport CO2 emissions in black and the transport consumption in orange. The ratio between the two is called the carbon emission factor and is in gray on the figure. We observe a decoupling of CO2 emissions and consumption of transport with a decrease in carbon emission factor since 2018 and between 2004 and 2012 for both periods, thanks to a progression of the share of biofuels and electricity, which are non-carbonated fuels. In 2022, CO2 emissions were only 1.5% higher than in 2000, while consumption was 18% higher, so much higher. Now Bruno will present you the energy efficiency trends. I let him the floor.
Hello, everybody. So I will explain to you what we can say about energy efficiency. You will see it is not easy to draw conclusions. The sector has been much affected by the COVID crisis. In 2020, in 2021, there were remaining effects, and in 2020, there were high fuel price for transport, and all this had big influence. We can consider that the period until 2019 is more representative of the historical trends, although, as you will see, the transition for car really started in 2021, 2022. So it's a bit complicated to present. The energy efficiency progress in Odyssey is captured at the level of the different mode of transport, types of vehicles with physical indicators. We use liter per 100 kilometers, which for vehicles will be less and less relevant because of electric vehicles. So we'll use KOE per kilometer, KOE per passenger kilometer for passenger transport, KOE per ton kilometer for freight, and so on. We will give a special focus on car, as was explained. They absorb half of the consumption of the sector. And for car, we monitor energy efficiency for the car stock and for new cars separately. New cars will tell you what's going to happen in the future, where the car stock gives you the average and the situation for the different years we observe. For the car stock, we use liter per 100 kilometer, but as I say, for the stock, it's still relevant because the penetration of electric vehicles in the stock is still limited. But we'll shift to KOE per kilometer to well take into account the substitution between fuels. And we also use KOE per passenger kilometer, PKM, which can be compared with other modes. And when we did some work with the Commission to select what would be the best indicator to capture energy efficiency progress for cars, the European Commission proposed to, as a preferred indicator, the KOE per passenger kilometer, which is what we are using now. But we are finding out it is a bit misleading, and we may have to go back to what we used before, the KOE per kilometer. For new cars, the specific consumption corresponds to theoretical value based on tests, and with the new tests since 2019. And so it can be in liter per 100 kilometers for thermal vehicles. These numbers will be given in an annex, and in gram oil equivalent per kilometer for all cars. And
Bruno, I guess you coincidentally hit your mute button. Yeah, okay, there you are again.
What happened? I did not mute. Okay, sorry. So for cars, on this graph, you see the message we can draw from the different indicator used. In orange, you have the KOE per passenger kilometer. in dark blue in the middle, you have the QE per kilometer. And in blue, this is the change in the occupancy rate, the average number of persons per car. Usually, the QE per kilometer has been decreasing faster since until 2019. But over the period post-COVID, we have very strange variations with very significant decrease in the occupancy rate, which affected much all the indicators. For 2020, we understand why there was a drop in the occupancy rate, but based on official statistics from the countries, it seemed in 2021, the occupancy rate did not really change for cars compared to 2020, which is a bit surprising. The efficiency of vehicle measured by the indicator in QE per kilometer has been decreasing by 0.5% per year until 2013 and since 2019. And if we focus on the overall efficiency in QE per km, which is what we are using officially now, we can see that there has been little progress since 2014. And this is much linked, first of all, until 2019 to the fact there were a greater share of big cars, the fact there were less diesel car and more gasoline car, which are less efficient, and since 2020, the decrease in the occupancy rate. For new cars, the specific consumption of new thermal and electric cars has decreased rapidly by 5% per year. So this is completely different from the trend we see from the overall stock, which is explained by the fact that the overall stock is still not much influenced by the new cars. And also this is considered to theoretical value and does not include the behavior of the drivers and so on. The greatest progress were observed in Sweden, which is again leading in this area because of the high penetration of electric cars, and in Finland. This improvement for new cars has accelerated since 2020 with the rapid penetration of electric and hybrid cars from 3% in 2019 to 22% of new cars in 2020 at EU level. For the car stock, energy efficiency improvements for cars have been limited until 2019 and have deteriorated since then, as I explained earlier. And you can see contrasted situation among the countries, with some countries showing significant improvements, like Greece, Ireland, or France, which is partly due to a shift to smaller cars, in general to more efficient cars, and also it can be also behavioral effects, like in Greece, due to high price and the economic situation in Greece. This contrasts with the situation observed with new cars, as I explained, because they correspond to test value and they did not yet influence the car stock. For road freight transport, trucks, we can see at EU level that the consumption per ton kilometer, the unit consumption, which is the indicator of energy efficiency, has decreased on average by 1% per year since 2000, reflecting energy efficiency improvement. This trend has generally everywhere accelerated since 2014, which is a situation contrasting with car where we can see a more deterioration in recent years. And the energy efficiency progress for trucks has reached 1.6% per year at EU level. So 0.3 or 0.4 points per year more than before. And this is due to the combined effect of increase in load factor. So it's a management effect, transport management effect, and technical effect, the fact there are more efficient vehicles. Now we have an indicator that summarize the trend in the different mode of transport. We have trucks, car, light-duty vehicles, motorcycle, and so on, that we call ODEX, which is calculated by looking at the energy efficiency trend for the different type of vehicle, and we look at what happened at the level of 8 mode of transport, and we calculate an average index for the sector by weighting the progress by type of vehicle, by mode of transport, by their share in the energy consumption of transport. We can mix different units, so this is quite convenient by using this approach, since we weight index and not absolute values. So it's a mix of KOE per vehicle kilometer, per passenger kilometer, per ton kilometer, and so on. The trend in the ODEX is shown on this graph. We did not show the 8 mode of transport because it would look like a spaghetti, so it's not easy to see. We only kept the most important one. And in black, in the middle, you have the weighted average, which takes into account the 8 mode of transport. We can consider that the energy efficiency of transport has improved by 0.7 per year since 2000 at the EU level. So it means an overall progress of 13% over the 21 years. The progress is the lowest for cars, whereas the most important progress were for trucks and light vehicles, especially since 2014 or 2012, in the middle of the last decade. Since directly after the financial crisis, there has been no more progress because of the fact that the management of freight traffic was not optimal, with a lot of empty running and low load factor. The greatest progress were achieved for domestic air transport because of the renewal of the fleet with very efficient plane now. Energy efficiency progress has saved every year since 2000 an additional volume of around 1.7 million ton oil equivalent per year, which is not so important at EU level. And these annual savings have decreased by 40% since 2014 at the EU level, after a peak at 2.4 MTUE over 2008-2013. So this illustrates the degradation of energy efficiency in the recent years. Cumulated, these savings reach 39 MTUE in 2022, and which means that without these savings, the transport consumption would have been 14% higher. Trucks and light-duty vehicles are overrepresented, since, as I explained earlier, we saw less energy efficiency progress for cars, despite the fact there are more measures on cars than on trucks or light-duty vehicles. If we compare the savings for transport with the overall savings, we can see that transport is underrepresented. Its share in the total savings for end-use sector is only 17%, which is a share twice lower than the share in the consumption. So this sector is not well performing in terms of energy efficiency improvement compared to the other sectors. If we look at another component of energy efficiency, which addresses the issue of shifting to more efficient modes, first for freight, we can see that the picture is not good also at this level. The share of rail and inland waterways, which are more efficient than trucks, has been decreasing since 2000 in 2/3 of the EU member states. And the trend has slowed down since 2010. However, a few countries have experienced a shift from road to rail and water, which is the opposite to the general trend. And the top runner is Spain, with 3 points improvement, followed by Finland and Italy. And Lithuania, Latvia, Romania, and Netherlands are the leading countries in terms of the share of these efficient modes in total traffic with a share around 50%. With respect to passenger, the situation is that it's why we have added two close year 2019 and 2021 on the graphic. The situation has very deteriorated since 2019. There has been a significant reduction of the share of public transport in most countries since 2019. At EU level, the decrease was 4 points to 15% between 2019 and 2021. If we look at the period before COVID, there was a decreasing share of the share of public transport in 70% of the country, and at EU level, the share of public transport decreased by 1 point. So all this goes in the other direction than expected and anticipated by policymakers who would like to increase the share of public transport. There are, however, some countries where there is, since 2010, a progression of the share of public transport, but until 2019, because of the effect of the COVID since 2019. And Sweden also is a top runner again here, followed by Slovakia. And the highest share was in Czechia and Austria. Now, to conclude, let's say a few words about how we can explain the variation of transport. And all these indicators are combined in a tool that is available on the website of Odysseus, which is called the decomposition tool, where we try to explain why the consumption has changed between 2 years. So the first slide I will show you is for the period 2000-2019, that is to say before the perturbation created by the COVID, where we observe an increase in traffic, which is the what we call the activity effect, with an equal role between freight and passenger, which contributed to increase the consumption by 48 million ton oil equivalent. Again, as what I just explained, the growing share of inefficient mode of transport, what we call modal shift, contributed to increase consumption by around 6 million ton oil equivalent. Two big drivers of increasing the consumption, which have been offset by energy saving, which offset half of this activity and modal shift effect, which explain why the consumption only increased by 27 million ton oil equivalent, more or less than half of the activity effect. Since 2019, here I will include the year 2022 based on the first estimate that we have produced, which take into account the effect of higher price in 2020. Between 2019 and 2022, the passenger traffic has contributed to raise the final consumption by 6.5 million ton oil equivalent, while the freight traffic only increased by 3 MTUE. So there is a different mix between freight and passenger in the activity effect compared to the previous period. If we had stopped in 2021, this would have been completely different, and you can see that on the website of Odyssey, as in 2020, there was a rebound of passenger traffic. Modal shift contributed again to increase consumption because what I explained, and this is both for passenger and freight, and energy saving offsets around 3/4 of the activity and modal shift effect. In 2020, we have a big other effect, and this is something that we can explain by the significant increase in motor fuel price, which was in the range of 15–20%, reaching very high level in many countries, which led many governments to put some kind of subsidies or support to reduce the increase in the motor fuel price. So this is what we can call constrained sufficiency. And To conclude now, before we go to the question, as you can see, transport has been much affected by the COVID crisis, not only in 2020, but still in 2021. And then in 2022, we have the impact of high price increase. The energy efficiency progress for cars has much deteriorated since 2019, and we expect in 2022, depending on the indicators, we'll see some improvements starting again, and we can expect, given the trend for new cars, that in the future, this should accelerate for cars. The transition to alternative fuels is hardly visible in the consumption, but has accelerated since 2020 with the rapid penetration of electric cars. Trucks and light-duty vehicles have better results than cars and they represent a significant share of the savings. Transport sector lags behind all the other sectors in terms of energy efficiency improvements, if we take into account its share in the consumption. And only very few countries have managed to reverse the trends towards a bigger share of cars and trucks in the traffic. And the COVID, until 2021, had a big effect to reduce the share of public transport. We expect that in 2022, we should be back to the situation in 2019. All these factors explain why the consumption and emission are increasing again back to the trend we had before the financial crisis, so rapid increase. And in a conclusion, we can put in comparison this growth in the consumption to the number that is shown on the left. What should be the trend in the consumption of transport to reach the NDC goal to reduce the greenhouse gas emission, which, according to our scenario, would imply a decrease by 2.5% per year of the consumption in transport, which is far from being the situation presently. So we'll close here and we can go to question now.